Hello everyone, in this video let's discuss about toggle flip-flop. We can also call it as T flip-flop. How to get full on full marks in this topic. So to get full on full marks we must follow 5 steps. First one will be of block diagram. First one will be block diagram. Next, second, using this block diagram, we must write the circuit diagram. Circuit diagram. All will be easy, simple. I will tell. Third one will be truth table. Truth table. Using the circuit diagram, we will write the truth table. Now, using the truth table, we will be writing the characteristic table. Characteristic table. Using this characteristic table, we will be writing the excitation table. We will be writing excitation table. Now let's write one by one. So first one will be block diagram. Block diagram. How to write block diagram? In block diagram, we must represent the inputs and the outputs that we are using. So in every flip-flop, all the types of flip-flop, that is T flip-flop, D flip-flop, JK flip-flop, in all flip-flop, we will be having two outputs, that is Q and Q bar. You can represent it using Q bar or A bar, B bar, anything. So what it tells is, if Q value is equal to 0, Q bar value must be equal to 1. If Q value is equal to 1, Q bar value must be equal to 0. That is, whatever the output value you will be getting, another must be the complement of it. That is opposite. So both this output cannot be same. They must be complement of each other. Now let's discuss about the inputs that we must give in the toggle flip-flop. One input will be T. As we all know that toggle flip-flop will be having T as an input. Another second will be clock. We will represent clock using CLK. So the clock input will be same for all the types of flip-flop. In JK flip-flop, in D flip-flop, all flip-flop, one common input will be clock. Now we finished the toggle flip-flop block diagram. Second one will be circuit diagram. Circuit diagram. So to write the circuit diagram, first let's design the latch. So we can design using NAND gate or NOR gate. NAND gate means AND gate, in front of it NOT gate. So one output will be Q, another output will be Q bar. So the output will be input to this one and this output will be input to this one. Now we designed the latch. We need flip-flop. So I will add another NAND gate. So now one common input is T. So the T will be the input to both this NAND gate, and I said clock will be the common input to all types of flip-flop. So therefore clock value will always be equal to 1. Clock value will be always equal to 1. Now third step, let's write the truth table using this circuit diagram. Truth table. So while writing the truth table, what are my inputs? T and clock. So the clock value will always be equal to 1. So I don't want to write it again. So only input left is T. So only one input is there, and what will be the output? Output will be Qn plus 1. So what is Qn plus 1? New state output. So it is new state output. Qn plus 1 is new state output. Since I have only one input, what will be the combination? 0 and 1. When T value will be equal to 0, the output, that is new state output, will be equal to Qn. What is Qn? Previous state output. Previous state output. When toggle, that is 0, no input will be given, then the output will be equal to previous state output. When toggle is equal to 1, that is input is given, the output value will be equal to Qn bar. That is new state output value will be equal to Qn bar. Qn bar means complement of the previous state output. Complement of previous state output. Now, fourth one. What is fourth one? Characteristic table. Characteristics table. So I said characteristic table will be designed using this truth table. So what are my inputs in the characteristic table? One is T, another one will be Qn. So what is Qn? Qn is the previous state output. Next, my output will be Qn plus 1. Qn plus 1 means new state output. Since I have two inputs, what are my combination? 0, 0, 0, 1, 1, 0 and 1, 1. Now, I already said using the truth table only you must construct the characteristic table, because what is the value of T here? 0. When the T value will be equal to 0, the output will be Qn. So output will be Qn value itself, same. Next, when the T value will be equal to 1, the output value will be complement of Qn, that is complement of previous state. When T value is equal to 1, complement, 0 will become 1, 1 will become 0. That's all, simple. Next, fifth one will be excitation table. Excitation table. To write this excitation table, you must take the reference of characteristics table. So what will be the inputs? Inputs will be previous state output Qn and present state, that is new state output Qn plus 1. These both will act as an input and output will be T. I said take the reference of characteristics table. Since I have only two inputs, my combinations will be 0, 0, 0, 1, 1, 0 and 1, 1. When Qn value is equal to 0, Qn plus 1 value is equal to 0, what will be the T value? 0. When Qn value is equal to 0, Qn plus 1 value is equal to 1, what is the T value? 1. When Qn value is equal to 1, Qn plus 1 value is equal to 0, what is T value? 1. When Qn value is 1 and Qn plus 1 value is 1, what is the T value? 0. So this is the excitation table. Now if you want to write the characteristic equation, how can you write the characteristic equation for the output? You will write now Qn plus 1. So where the Qn plus 1 value is equal to 1? Here and here. So what are the value? T and Qn are the inputs. No, T value is 0. So I must write T bar Qn plus. Next in here T and Qn value is 0. So T Qn bar. Qn bar means complement. So T value is 0, Qn value is 1. T value is 1, Qn value is 0. So how can we simplify this? T XOR Qn. T XOR Qn value will be the characteristic equation. So I hope the toggle flip-flop video is helpful for you. If you like the video, please subscribe. If you have any doubt, please comment below. Thank you.